Today we're going to cover the periodic table. The periodic table is set up so that you have your groups up the top and they run from group 1 here all the way across to group 18 at the end. What your groups do is they run down your page as you go across. So group 1 is all the elements that are below that. Group 2, all the elements that are below there as well. Elements that are in the similar group have similar properties to each other. As you move across the periodic table, the groups get different, and there's different things about them, and they can do different things. They react differently. They have different boiling and melting points and all that kind of stuff. But what you need to know is that there's 18 groups. Your groups are the vertical columns of the periodic table, and they're numbered from 1 to 18. The next thing that you need to know is your periods. So the groups are the ones up the top, the periods are the ones that run down the side, so from 1 all the way down to 7. And these ones, the way that you read them is you read them across the page. So period 1 is all the elements that are in the top row. Period 2 are all the elements that are in the second row down here. So as we go down, the elements get bigger. So if I was to look at an element of, let's see, arsenic over here, it's going to be a lot bigger than if I looked at nitrogen. And I know that because the further down the row, the periods of the periodic table that I go, the more electron shells that they need to have. So if my element's in period 1, then it has 1 electron shell. If it's in period 4, however, then it has 4 electron shells. So the way that I know how many electrons it has and how many protons it has and how many neutrons it has and all that kind of stuff comes down to, let me bring this back up nice and clear again, comes down to how you read the periodic table. So if I look at hydrogen, I'll get that right over in the corner here, I can see that it has a little 1. The numbers in the top corner tell me how many protons my element will have in its singular form when it's an atom. That's what that number tells me. The number down the bottom here is my mass number, and that tells me how many protons and neutrons my atom has. So if I was to look at krypton over here, I know that the atomic mass is 83.798. You'll have to excuse me, it's a bit small for me to read. So I know that. I know that that's what that means. It's just a given fact. The top number, the smaller number will be my atomic number, the number of protons. If it's not charged, and this is important for you to remember for later, if it's not charged, then my number of electrons will be exactly the same as my number of protons. Remembering that my protons have a positive charge, my electrons have a negative charge, and my neutrons are neutral. They have no charge whatsoever. So we've got our groups that run down our page, our periods that run across the page, and we know how to read our elements a little bit better as well. So if I was to pull up oxygen here, I know that this one here is my atomic number, and I know this part here is a symbol for that atom, because we have different symbols to tell them all apart. So when we're writing our chemical formulas out later, you don't need to write the whole name, which is just below it here. You can just use the symbol version instead. And the bottom down here is my atomic mass. So my atomic number was my number of protons. And my atomic mass down here is protons plus neutrons. So remember, if I just wanted to get protons by themselves, just wanted this guy here, then I need to look at my atomic number. But if I want to know my number of neutrons, I can take my atomic mass and subtract my protons, because that'll leave me with my neutrons just by themselves. So if we go back to our periodic table, now you should know what your groups are, what your periods are, that the further down the periodic table you go, the bigger that the element will be, the more shells that it will have, and you should know how to read each element on the periodic table. So oxygen is number 8. And where is it on my periodic table? Find number 8. So I've got 1, 2, 3, 4, 5, 6, 7. So it's over here. It's number 8. So it's in the second period of the periodic table. So I already know that it has 2 shells. My first shell can hold 1, 2 electrons, and I'll have 1, 2, 3, 4, 5, 6 electrons in my next shell. So let's have a look at drawing oxygen. So I need 8 electrons in total. So in the middle here, I'm going to have my protons and my neutrons. They're in the nucleus of my atom. And then around it, I have those shells. So I have my first shell, and I have 2, that's not a very good color for you to see, 2 negative electrons. Then I have my second shell, and I go 8 minus 2 gives me 6. So I need to fit 6 more into this shell. 1, 2, 3, 4, 5, 6. So I have 6 in the second shell, 2 in the first. If I go back to my periodic table, second period tells me that I should have 2 shells. So that's pretty handy. The next thing that you need to know about the periodic table is what all of these different groups are and what they mean. So let's have a focus on group 1, and the color coding tells me that group 1 is an alkali metal. So what alkali metals are is that they have a low melting point and they're pretty reactive. The further down the periodic table that I get, the more reactive these metals become. So it just means that they're going to react really strongly to other things that come in contact with them. They're going to really want to get rid of their electron that they've got, because these guys only have 1 electron floating around their outer shell and they just want to get rid of it to make their lives a little bit easier. If we have a look at group 2 and our color coding, that tells me it's an alkali earth metals, and these guys are pretty similar to group 1, they're just not as reactive. So they still have a pretty low melting point, they're pretty soft. It's hard to, the group 1 metals you can't really have just laying around in front of you. They kind of need to be kept pretty safe. The group 2 ones, not so much. You can kind of have them, and they're pretty soft. You can squish them a bit. They still have a low melting point, and they're still pretty reactive when they want to be. Groups 3 to 12, I think I have in here. 3 to 11. These ones here are my transition metals. Some guys in here are going to be magnetic. Some guys in here are not going to be magnetic. If I look at gold and copper, they're the only 2 transition metals that I have that aren't shiny, and silver. So the rest of them are all going to be shiny and silver, which is pretty handy. When they combine with other elements in your periodic table, they make colored compounds. And remember, compounds when we have 2 or more different elements that are combined together. So that's what my compound is. If we keep going across, I have something that we call metalloids, and they sit in a staircase pattern on my periodic table. And my metalloids have properties that are similar to metals and similar to the group that sit next to them, which are the non-metals. So they take properties from both sides. These guys here can still conduct electricity in some situations, similar to the way that metals can. But the non-metals, they can't do that. So it's got some properties that come from both sides. So they're pretty useful. As I said, the next group that we have is our non-metals, and their properties are pretty different to when we look at metals. So they're not shiny. Most of the time they start to become gases. You can't manipulate them, and they have a whole range of melting and boiling point temperatures. So where before we knew that all these guys in group 1 have pretty low melting points, I can't say the same for these non-metals that sit in this group here. I can't say that. They've all got a different temperature that they're going to melt at. Within our non-metals, we have 2 other groups. Group 17, I'll clear off my periodic table for you here. Group 17 here are what we call the halogens, and I'll write that down because it's not on the screen for you. Halogens. And the halogens react with metals, and they're going to form salts when they do that. So these guys here are going to react with any of the metals, and they're going to form a salt every time that they do that, pretty much. As you go down, as I go down this group here, my melting and boiling points increase. So if I compare fluorine to iodine, the melting and boiling points of iodine are going to be a lot higher than they are in fluorine. The next thing that you need to know is a little bit different to group 1. When I went down group 1, my elements become more reactive. When I go down my halogens, they become less reactive. So they're kind of opposite to each other in that way. The last group that you need to know about is group 18, and these guys are our noble gases. And what our noble gases are is they have a full outer shell. So remember we talked about going down our periods, their shells on their outside that makes them their biggest is completely full. It can't take any more electrons, it can't get any more negative. It doesn't really want to gain anything because it's already pretty happy. It's got everything that it's got. They are all gases at room temperature and they're inert. And all that inert means is that they're unreactive. So the noble gases that we have over here are pretty different to our alkali metals that we have in group 1. And that is our periodic table.